G'day, so in this we are looking at application of straight line graph, specifically a distance and time graph. So I've just done a bit of setup on parts A and B to save a bit of time. So with this, we've got a cyclist rides at a constant rate of 20 kilometers per hour for 4 hours. So we've got a few parts to this question. So we've got draw a table of values using T for time and hours, D for distance in kilometers. Use two values between 0 and 4. So I've already set up this table here and you'd be familiar with this. So we just need to apply. So when they've travelled for 0 hours, they haven't moved yet. So they've actually gone nowhere. So our distance will be 0. Okay? Now, after 1 hour, if they're going 20 kilometers per hour, after 1 hour, they've gone 20 kilometers. So it's 20 times 1. After 2 hours, if they're going 20 kilometers per hour, that's 20 times 2, so that's 40. And I think you can see a bit of a pattern here. It just goes up by 60 each hour that you go up. Okay? So we've got our distance and our time there. So now we need to plot a graph. So this is always important. Time, whenever you're doing it in a question, it's always going to be on the x-axis. Okay? And you can see that's what I've done here. And I've put a label, sorry, it's not written perfectly, but I've labeled our axis distance and I've put the units what it's in as well, distance and kilometers. You can see here that each notch goes up by 10 on the y-axis and each section I've got up here goes up by 1 hour. So you need to make an appropriate scale for what you're graphing over as well. So it's always good to sort of do this table of values first, just so you have an idea. So we're going to plot these. And I'll do this in red. So 1 hour's 20. Got that there. 2 hours is 40. Got that there. 3 hours is 60. 4 is 80. Okay. So I've plotted those points and done part B there. Okay. So write a rule linking D with T. Oh, sorry. When you do this, actually, it's best to draw a straight line. I thought that was another question in this one, but it's not. Draw a straight line showing your rule. You will notice why I haven't gone into the negatives like our normal graphs. You can't go a negative distance or go in negative time in this example, so I'm only dealing with the positive values. That's why I've only got the positive section of the graph there. Okay, so that's why I've only got that first quadrant there. Okay, so C, we need to write a rule linking D with T. Okay, so yet again, with 0, where our x-intercept 0, our y-intercept 0, so it's going to be in the form of y is equal to mx. There won't be a c, okay, because our x and y-intercept are both 0. Now we just need to work out how much it goes up by. So you can do this by putting into a point. Putting into our point or figuring out our gradient. So with this, we'll just figure out our gradient. We go across 1. Oh, sorry. So m is equal to rise over run. So you can see here, we go across 1 is our run and go up 20. So we'd have a triangle like this, obviously not to scale. So our rise is 20, our run is 1. So our m's 20. So it's going to be y is equal to 20x. And I like using y is equal to mx, but then we need to put it in terms of distance and time. So y is our distance. So distance is equal to 20 multiplied by our time. So that's how we can put it into D is equal and T. I just set it up as y is equal to mx, just so you're familiar with how to do this. All right. So now we need to use this rule. So use this rule to find the distance travelled for 2.5 hours of cycling. So with, just set up a bit of a separate section here. So with D. Okay, 2.5 hours of cycling, we just substitute T is equal to 2.5. So distance is going to equal 20 times 2.5, which you can work out to be 50. And remember, this has units. Our distance got to have units of kilometres. So make sure you put that there. Okay, and then finally, E, usual rule to find the time taken to ride 60 kilometres. So they've ridden 60 kilometres, now you need to work out time. So we just need to substitute D is equal to 60 and solve for T. Okay, so 60 is equal to 20 times T. Okay, so we divide both sides by 20. T is then equal to 60 divided by 20, which is equal to 3, and our time is in hours. Okay, so there are normally a lot of parts that can be done in application questions. It's just important to break down, and then if you need to, do your table of values so then you can draw your graph. Okay, then from your graph you might be able to find your rule using the gradient formula, and then you might need a point on it to find C depending on what values you have. And then just remember, you can substitute, once you have your equation, you can substitute in known values to find another value like down the bottom there. So hopefully this helps with breaking down some application questions, especially with looking at distance and time. So hopefully this helps, and good luck.